Okay, total quality management. I really like this chapter. You may have noticed I really like most of our material that we cover in this course, but I really like this chapter because it is extremely practical. We're going to not just learn, but we're going to use the tools that everybody uses when they're doing Six Sigma quality. So learning these pays great dividends. Being familiar with these, and I think you're going to find many workplaces talk about quality and maybe even talk about Six Sigma quality, but very few do it, and they don't realize how easy these tools are to use. And then suddenly they send their people to black belt training, or as the introduction is called, green belt training. And suddenly they do exactly what we're learning in this chapter. So if you ever see an opportunity to take an online green belt course or whatever, do it, because you'll get certified and you're basically going to do exactly what we've learned in this chapter. So you are going to be totally prepared on this. So the foundation of the Six Sigma process. Now, I will mention Six Sigma briefly. I like the concept, and I don't have the exact numbers with me. I'm so embarrassed. But we often talk about quality. I want to be at the 95% level. I want to be at the 98% level. And the Six Sigma level of quality means, like, and I'm so sad that I don't have the number with me. I almost will stop the video and redo it, but I'm not going to redo it. It's like one error for every 4 million items produced. It means that your error rate is so ridiculously low, it's insignificant. Because at a 98% level, you still get 2 errors for every 100, and the Six Sigma people say that is absolutely unacceptable. So it is awesome to be targeting working at the Six Sigma level. And as you can see by my mistake I've already made by not knowing it, I'm not operating at a Six Sigma level right now. Sorry. So the process, though, is this DMAIC, and this is universal. And so if you're in an interview for anything, or you're talking to somebody and they go, oh, we do Six Sigma quality, they're going to go DMAIC, or you're going to say it, and they're all going to know exactly what we're talking about, because this is the process. We define exactly what quality means for the process that we're looking at. So we're very careful to identify and clarify what process we're looking to investigate, and it excludes all other things. So it's really important to define what it is, what process we're looking at, and then what it means to have quality in that process. And that builds on some of what we discussed last week with the dimensions of quality. So we want to just say, oh, it's good quality process. No. What does it mean to our customer when our quality is exceptional? So very careful defining of what quality is. Then we measure it, and we talked about being quantitative and really using concrete, specific measures. How will we measure it? Is it by weight, height, width, surveying the customer? What exactly? Is there a checklist we use? What exactly is quality as we measure it? Then we'll analyze it to see if we're actually achieving the quality that we anticipate. We'll interpret that data that we have collected. Then we will identify ways that we can improve the process, the inputs to the process, the training of the people who operate the process, the technology that's used in the process, all of those things that we think will then enhance that quality measurement. And then we will control it, which means we will actually run the process with the improvements in it, and we will check to see, measure again, if we have actually achieved what we set out to. So the DMAIC is universal. It will roll off people's tongues. If you go to a Six Sigma green belt training or Six Sigma black belt training, this is the standard. So if you're familiar with it, you're already ahead of the game. These are not rocket science, but they're just so powerful when we look at quality. And then as an organization, if we're really serious about improving quality, this is the process you go through. The other thing I'll add on to this is a big part of Six Sigma is that ongoing improvement, analyzing and controlling, where if a quality failure occurs, based on how we've defined quality, if a single quality failure occurs, we grab it and we investigate it, and we find what's called the root cause of that quality failure, and we correct the process to make sure that that quality failure will never happen again. That's how, in a Six Sigma organization, we get to one failure in 400,000 occurrences or 4 million occurrences is because you're going to fix things such that you never have the same problem twice. Pretty awesome kind of thought, and companies are doing it extremely successfully. They are very motivated to do it because they know when you reduce quality failures, you improve the customer experience, you grow your market share, you reduce your costs, you increase your profit. All of the good things of business happen when you do this. So let me run through these. These are extracts of visuals of these quality tools from the text. So it's going to be similar, but I want to give a little bit of verbal explanation, not essentially of what they do, but why we use them. Number one, and these are not necessarily in order, the flow chart. The flow chart is what we use to document the process. And think of a process such as registering for courses at Towson University. What do you do as a student? You log into the system. You query the course that you need. I don't know what you do. You select it. You put it in your shopping cart. You check out. All that, and that's what we would do. We would pick that process, whatever that is. It could be going into the Enactus Cafe and purchasing your lunch. So what do? You walk in. You look in this cabinet. You look in that cabinet. You select the items. You go to the checkout. You pay. We would really break that entire process down. We would use a team to do this. We would gather people together, customers, the people that are actually running the process, people from elsewhere in the organization, because we want to talk through these steps and make sure we really understand, are these all the steps? Is this what really happens? And you can see from this diagram, we use the traditional flow charting diagram symbols you may have seen before, these diamonds, these squares, these I don't even know what to call that end button and that begin button. We call them connectors actually in flowchart speak, but they're often round circles, not this little shape, but hey, we get the idea. Decision boxes are the diamonds. So there's a specific tool set, and they're available everywhere. They're even actually built into PowerPoint and Microsoft Word, so they're readily available. But before we begin this quality analysis, the first thing we do is we document the process so we make sure we understand what's going on. And you see these little blue arrows and words out to the right. These are failure points in the process. And so after we document the process, we identify where are spots that things can go wrong. So if you're standing in front of the case in the Enactus Cafe and you're about to select your lunch item, one of the failure points is they're out of selected items. Or maybe those items are out of date, they're expired. Those are possible failure points, and then we would work to ensure that those failures do not occur. But the flowchart's just a real foundational part of doing this. When you do this in a team, it's often called a Kaizen Blitz. You'll see that listed in the chapter. It's a Japanese word, and it means that we assemble a group of people that can that have a familiarity with the process, and we attack it. And we do this DMAIC process, and we implement those changes, and then we continue to monitor. So the flowchart's the starting point. Check sheet, really simple way to quantify defects or failures. And so what we see on the left, and you can organize these in many different ways. You've got one that we're going to do in our homework. It might be organized by time. It might be organized by product on the left-hand column, and across the top, the different ways it might fail. So in this case, we know that on Monday between the hours of 8 and 9, 4 of our units were produced missing labels. 2 of them were off-center. Between 9 and 10. So instead of getting to the end of the day and saying, how many quality failures should we have? Oh, there were 9. This gives us additional detail of time and what the exact failure type was. With the intent then that we'll make all these changes to the process, we'll do our check sheet again, and we'll hopefully have better data. This allows us to also calculate percentages, failure percentages in the hour. Now from this data we can't do that because we don't have the total units produced during that time, but at least we have some measure of our quality failures. We can put our finger on it. We can see if it's varying by time of day, type of failure. We can see that off-center is a huge problem. We can see that smeared print is the next largest problem. So the check sheet is the starting point of quantifying and measuring quality. And you will do this in Excel. I give you the data. You're going to build a simple table. Maybe it's a yes, no, fail, pass. Maybe it's got times, I don't know, but you can build a really simple table in Excel. That's step one in your homework. Second tool is a Pareto chart. And basically what we've done is we've taken this data from the check sheet and we've converted it to a column chart. Pareto, remember, is an Italian guy from way, way, way back. He was an economist. And Pareto is the 80-20 rule, 80-20 rule. And he observed in Italy that 80% of the land was owned by 20% of the people, which to us here in the United States, we realize that's really messed up, because that means that 20% of the people are controlling 80% of the people, which is not too cool. It's a situation where there's landlords and things. People don't have control over their lives. So we would frown on that. Pareto got a little upset about it as well. But what we learned is that if we look at our problem categories and we sort them from highest to lowest, type of defect A, B, C, D, the highest is on the left. There's almost 140 errors of type A. As a Six Sigma black belt person, then I would say, hey, the first problem we should solve is A, and almost 140 of our problems immediately disappear. And then the next thing we should do is B, which it has 80. So let's figure out what's causing B and fix it. And then 80 more of our problems go away. So Pareto tells us to just kind of relax, find the biggest category, fix it first. So Pareto equals priority. It helps us prioritize our errors. Now I'm going to mention here for just a minute, because there's another tool, and I'm not sure that's going to appear in my slides, called a histogram. A histogram is a Pareto chart, same thing, but it's not in order. So a histogram kind of comes first, where we just say, what are all the categories? From our check sheet, we would have taken missing label, off-center, smeared print, looser folded, and other, and taken those quantities, 5, 14, 10, 2, and 1, and we would have just put them into a column chart in Excel. And then next step, we would have put them in order, and we would have had a Pareto chart. So a histogram and a Pareto chart, really the same chart. The only question is if they're in order from highest to lowest, they're a Pareto chart. So here's a run chart. A run chart looks at our failures over time. Now if we think of our check sheet that we looked at a minute ago, then that would have been 8 to 9 o'clock, 9 to 10 o'clock, 10 o'clock to 11 o'clock. That would have been the time along the bottom, or what we call the x-axis. And on the y-axis, that's the number of occurrences. So a run chart's a really easy chart. In Excel, that's a line chart. So you put dots in there, and you allow the line to show. And what you're looking for are trends. Are there patterns? Oh my goodness. And if I go back up to our check sheet data, and I'm looking down at our times, it looks like we start high in the morning, we drop down around lunchtime, and then we increase in the afternoon. But if you put this on a line chart, it'll be really obvious. So that's why we do a line chart, in order to see if time is somehow impacting the number of failures we're having. It might be an upward trend, downward trend, pattern like a seasonal trend. You remember how to do that? You just create a line chart in Excel. Now, interestingly, here's my histogram. I wish it would have come up earlier. Histograms just show your categories as columns, but not sequenced from highest to lowest. So do your histogram first, just so we can get a little visual from your check sheet data. Visual check sheet, kind of cool. Some people will immediately look and go, oh my gosh, look at that. Then when you sort them highest to lowest, you get a Pareto chart. Scatter diagrams, up in the top left-hand corner. A scatter diagram is when we take any two variables. So in some cases we don't have two variables, but in most cases we can think of two variables, and we're looking to see if there's a relationship between these two variables. And in Excel, this is called an XY diagram. Sometimes it's called a scatter diagram. I believe the Excel term, when you look at, when you go to Insert Charts, it's going to call it an XY. And so you're going to designate one variable as X and one variable as Y. In this case, it's the number of errors per hour and the humidity. Now this, these dots, you never put a line connecting them, but you could insert a trend line if you remember how to do that from 350, from EBTM 350 or EBTM 251. You learned how to insert a trend line. This would be where you do that. Now visually I can look at this and see what the trend is, and the trend is it's low on the left and high on the right. That means that as humidity increases, our number of errors per hour increase. So as a Six Sigma black belt, this is really important information because it tells me that if I put an air conditioner in the production area and control the humidity, I'm going to get control of my errors. So it looks a pretty high likelihood that humidity is driving my problem. So these run charts, as a Six Sigma black belt or even as a green belt, I would be trying to chart in a scatter diagram all the different combinations of variables to see if there's any pattern. Now if when I ran my scatter diagram there were just dots all over the place, that would suggest there was no relationship. In this case, there's a clear pattern, low left to high right. The pattern also might be high left to low right, or it might be a U shape or an upside down U. We call that a convex pattern or a concave pattern. So we're looking for a pattern in these dots that would indicate there's a relationship between these two things. Down in the bottom, the next tool is called a control chart. Now I'm just going to give you a real high level touch of control chart because our next chapter digs way deep into control charts. The key to a control chart is that it is basically a line chart over time. You can see time is on the bottom. Time is always on the bottom of a control chart. That would be your x-axis. The y-axis is the number of errors. But what's unique about a control chart is this upper control limit, noted as UCL, and lower control limit, LCL. And I'll just give you a little hint here. Let's talk about temperatures of food products at Starbucks. When you buy a hot coffee, an espresso at Starbucks, you expect it to be hot. And the upper control limit would be what's the highest temperature that would be acceptable for that espresso. And the LCL would be what's the lowest temperature that would be acceptable. Really important concept, because when you get your coffee, you're paying a lot of money for it at Starbucks, and you expect it to be right. You don't want to get it and go, oh God, this is too cold, or it's so hot I can't drink it. There's a right temperature range. That's what a control chart monitors. And so we see our dots in there. That's our sample data. And if it's time, if we kind of think about this far left, that first dot is very close to the dotted line. It's within the control limit. So that coffee's probably okay. But as you see, we get further to the right, some of those are very low. That coffee's almost too cold. And so we're going to use a control chart to monitor a process and realize that, whoa, this coffee's starting to run on the cold side. Something's wrong. We better fix it. So control charts are a really important ongoing monitoring tool. We'll dig into those deep in Chapter 11 or Chapter 10, whatever the next chapter is we're doing. The last tool is called a cause and effect diagram, or a fishbone diagram, or an Ishikawa diagram. They're all the same diagram. They just have 3 different names. The concept, though, is a little hard to get into practice. What we do with an Ishikawa diagram, picture this being blank, and we decide that the error we want to fix is that airline tickets are wrong. And so that's why it's the head of the fish over on the far right. The other shaded boxes we see are possible causes of why airline tickets are wrong. And so this is another tool where we would use a Kaizen blitz, where we would have a group of people brainstorming, and we'd throw it out to them and we'd say, guys, what do you think might cause airline tickets to be wrong? And so we would you would need a facilitator such as myself to help people work through it, and they'd say, oh, well, maybe it's the printer. Ah, okay, let's put that in that top left box. And they say, oh, maybe it's because the person doesn't know how to put the information in. Oh, let's call that personnel in the lower left-hand box. Maybe it's this man. That's where these boxes come from. Then we go inside of those and we say, okay, if you think it's the personnel, what do you think the personnel are doing wrong that's causing it? That's where we come up with these little lines that are in between. Oh, maybe it's the training, maybe it's the supervision, maybe they just don't have the skills they need, they don't have the ability to do it. And this is a brainstorming exercise where we just keep throwing these out and mapping them into this diagram until it's full. And then we stop and we say, okay, group, let's do process of elimination. We may have to collect more data to do that, or we may have enough knowledge in this room to do it. And you start scratching these things out. And you say, well, is it the quality of the printing? No, scratch it out. Is it the speed of the printing? No, scratch it out. And you literally go through and scratch out each of these ones that have lines attached to them until there's a few left, and those are the ones you need to go fix. So cause and effect identifies all of the possible causes through a brainstorming activity, and then a process of elimination to narrow them down, and what's left you go try to fix, and then you measure the quality over again. So that is your kind of tool set for TQM. I know it was a lot, but it can kind of, I think, blur when you read through it, but try reading through it. I hope my description helps you understand how these really are used. We literally, wherever possible, use every one of these tools when we do our Six Sigma quality evaluation. It helps lead us to what changes we need to make. Then in the DMAIC process, we actually make those changes, we monitor, we measure again, and so forth. So these are what drive the analyze process in that. Let's try them out with homework 5. I give you some data and it allows you to actually use Excel to build out each of these tools that we just looked at.